At 291 Kelvin, molar conductivities at infinite dilution of NH4Cl, NaOH and NaCl are 129.8, 217.4 and 108.9 Simon centimeter square mole inverse. The molar conductance of 0.1 molar NH4OH is 9.35 Simon centimeter square mole inverse. What is the percentage dissociation of NH4OH at this dilution? Also calculate the dissociation constant of NH4OH. Now NH4OH is weak electrolyte. First we need to calculate the limiting molar conductance of NH4OH by using molar conductivities at infinite dilution of NH4Cl, NaOH and NaCl. Lambda m naught values for NH4Cl, NaOH and NaCl are given. First of all, in these three strong electrolytes, which is having two common ions, that we should identify, and that should be subtracted from remaining two. So here if you take NaCl, it is having two common ions. Na is a common ion in NaOH and Cl is a common ion in NH4Cl. So NaCl, lambda m naught value of NaCl should be subtracted from lambda m naught value of NH4Cl and lambda m naught value of NaOH to get lambda m naught value of NH4OH, because Na plus and Cl minus will get cancelled. What will remain? Lambda naught of NH4 plus and lambda naught of the OH minus will remain. That is the reason why we have to subtract NaCl from lambda m naught value of NH4Cl and lambda m naught value of NaOH. So lambda m naught of NH4OH minus is equal to lambda m naught of NH4Cl plus lambda m naught of the NaOH minus lambda m naught of the NaCl. Lambda m naught of NH4Cl is 129.8 plus lambda m naught of NaOH is 217.4 minus NaCl is 108.9. If you calculate the value, you will get 238.3 Simon centimeter square mole inverse. That is the lambda m naught value of NH4OH. And in the problem, lambda m value of NH4OH is given at 0.1 molar, that is 9.35 Simon centimeter square mole inverse. Now by using lambda m and lambda m naught of NH4OH, we can calculate alpha. Alpha is a degree of dissociation. Lambda m by lambda m naught, that is 9.35 by 238.3. Value will get 0.0392. Alpha value percentage is 3.92%. So percentage of degree of dissociation of NH4OH is 3.92%. And they are also asking to calculate the dissociation constant. Kb is equal to C alpha square by 1 minus alpha. C is 0.1, alpha is 0.0392 by 1 minus 0.0392. Here we will get Kb value, dissociation constant 1.59 into 10 power minus 4.